bees are building and maintaining the honeycomb in a hive following some simple and straight principles. The bees work along these principles for a bigger whole, to ensure the survival of the community. Engineers organize their best designs in nexiles.hive by following some simple and straight principles. The engineers work along these principles for a bigger cause, to ensure the success of the company and their products. These simple principles for nexiles.hive are: managed designs are called a template. Templates have assigned and are organized by tags. Every template is linked with an existing CAD model, UDF or material. Each template can be used as it is, or it can be configured. Every template is described with an informal data sheet. nexiles.hive provides means to set up simple rules for organizing dynamic content. This content is easily accessible for all designers. Preferred design solutions are easily found and reused. Things are streamlined and best practices are enforced and so easily available that they are preferred over inventing the wheel all over again. Here you can see the content of a demo instance for nexiles.hive. It contains a lot of different templates. From the whole selection of templates you can narrow down your scope by using tags which are assigned for each template. Here you can see all the UDFs. You can see some different parts. You can see, for example, a selection of the demo parts for Lego. And again, within these Lego parts we have a case where we want to sort them by colors. Let's say red, black, blue and gray. The same accounts for other models where you can see some Fisher Technique parts or some other stuff which you can organize the way you need them, dynamically, easily, very simple. In addition to filtering by tags, you can use a live search, which can be applied to all available content. Just start typing and you see a list of all the available matches. All to the right we have the cart, which is a part collection of all configured or selected templates. We're going to fill now one of the templates. We scroll down and use the flange shaft, give it a name, which so it has to be unique for the cart. Configure to the values according to our requirements. We can look at the different things for this cart, and by adding it, you're sort of adding it to a shopping cart, just like on Amazon or somewhere else. You get direct access to it, looking at the 3D model directly from Windchill with Creo View. In addition to that, you have a shortcut going directly to the info page of this template model within Windchill to look at all the details there. I'm going to add some more things to the cart. Right now it's a groove of a certain type. You see here also every template has some additional information, which is sort of the informal data sheet to explain for engineers what's this about. So for this groove, we keep the name, we do some different value, not the standard value, add it to the cart, close the dialog and save the cart. I'm switching now to Creo, showing you the client side of the application. I just log in using my regular Windchill credentials. And this cart is my personal cart. As you can see here, you see the same items I have added, and right now I'm using this demo shaft and generate a new copy of this template in my Creo session. Along with this copy, the template has defined a drawing. So the drawing is automatically loaded, a copy is made of this, and as you can see here, it's got the new value assigned, so we really created a new instance of this design. This design is not complete, we need to apply some grooves. As you can see here, you just pick them, pick the references, and by just walking through the different places where you want to add them, you just finish the design and complete the geometry and the design data. I switch back to the template selection, I clear all the filters, and I take away the groove again from the cart. Saving the cart. Now we can do the same thing for templates, not only for parts but also complete assemblies. Like you can see here, this heating battery. You just apply again a unique name. We change some dimensions of this assembly here, of this heating element here. The height 400 or 600 and then the duct width 400. We just add it to cart and save the cart again. Back in Creo, I open the Hive client again, I refresh the content of the client, and you can see here this heating element has been added. I just use it. It's loaded, we get a new copy of the assembly and the components, and it has been configured to the size we have specified. So the height should have been 400. Let's check this by measuring actually on the actual geometry. And as you can see here, it's 400 millimeters. Back in the template selection, I want to add some more things. I take now a shaft again, which you can just add, it's not configurable. We add in addition to that some special thing, which is sort of a gear geometry feature, where you can just again give a unique name and you enter all the gear details. To generate geometry, we add it to the cart and we make a second type, which will be different. So we give it again a unique name, and it should have a runout with 60 millimeters diameter, and the runout should be in the back. And actually we changed the direction of the helical direction. Add it to the cart again, and again we have the data sheet. Save the cart. And back in Creo, we just refreshed the cart. You can see now the shaft and the two types of gears. We used the shaft to take the model, just show the coordinate systems, and now let's place this gear geometry. It's loaded now again, regenerated, and I need to select the placement coordinate system, and we get a surface copy of this geometry. Let's take the second one, place that one as well. What I need to do is just use this surface model and say to remove solid material, and the resulting geometry is the actual gear geometry. So now you can see with the second one we have two different types of gears applied to the shaft, and the gears are according to the specifications as we have specified for the template. Now again I want to add some groove. Let's go back to the UDF, take the groove, make it 0.4 millimeters in the radius, add it to the cart, save the cart, switch back to Creo, refresh the cart, and you see the groove is there. Let's just use it, apply surface and the references on both sides actually, and this way we can complete our design here again. Back in the template selection, let's look at the whole list. It actually can be configured as well within this same application, where there is an edit mode which can be activated. And you see all templates in a plain list where you can expand them and look at the templates. This is sort of what an admin would do typically, or a lead engineer, to supply all the other designers with the best practices of the designs. Here can also new templates be added or existing ones being edited. Like you can see here, you have the datasheet definition, and you see also what kind of parameters are actually controlling the actual template with all the different types and descriptions and so on. This is nexiles.hive, a place where designers can easily find and reuse existing designs that have been identified to be preferred and serve as best practice for solutions for the company's products.